All right. Today's topic. I want to work on this Raspberry Pi bootloader shit that we've been working on. Um, maybe it makes sense to pop open. Maybe it makes sense to like talk about our understanding of the boot process. So we have this Raspberry Pi. He's got the little board. He's got like the dots in him, whatever. He's got his little chip here. Wow, Raspberry Pi. Right? This guy on here somewhere has some like read only memory, right? And in this read only memory is bootloader stage 1, right? Bootloader stage 1, his job is essentially to be like, oops, you fucked your shit up. I guess you might want to, fix your thing, right? You might want to program an executable onto this thing. So he sets up like USB and allows you to drag and drop a universal firmware image, I think UF2 image, drop him in there. And he knows how to like write to Flash and stuff, right? Once he's written to Flash, he has the ability to then look at like, there's also Flash on here. And this guy will be like, yo, is there a valid bootloader stage 2 on here in the first 256 bytes? Let me check. Let's like look at that data, look at the CRC. If the CRC passes, we'll like run it. Right? And so the question is how, and then the bootloader stage 2, his job is to like launch the rest of the executable, right? So in terms of like what's on Flash, this is like Flash. You have like bootloader stage 2. Then you have like a checksum, CRC, and then you have like the rest. The rest. And bootloader stage 2 job is basically just to like basically set up the rest and run it, right? So depending on how your program was linked, this stuff might be expected to be like copied to RAM, or maybe set up like execution in place, right? BS2 might be supposed to be say like, okay, we can like set up the Flash reading chip, I guess we can kind of call it, to basically just be like memory map the whole fucking shebang. You can do, his job is basically set up the rest. But we're kind of more interested in basically how to run this guy. So we have this like demo code that should work, if I remember correctly. So we have like the world's stupidest boot stage 2. All he does is he like sets a register to 100 and then adds 1 to it infinitely. He just forever is like add 1. And we're like, okay, cool. And the compilation process for this is a little fucked up. We're kind of copying what the SDK of the Raspberry Pi did for their stuff. But we compile that file into a .o. This is like a normal assembly file. We then copy out all of the like relevant data into like a binary file, just like a raw blob. This thing will be like relatively small, right? So we do like build boot to bin, right? This thing's 8 bytes, right? Then we call like a Python script that basically like pads this thing out and checksums it and spits out a new assembly file. And it's like, so here we see like the actual byte by byte data. So this is like kind of the executable we compiled, then a fuck ton of zeros, then a checksum, right? This assembly file also requests that this gets put in the boot2 section, which is useful because it means that when we link our final executable, we can say, make sure that this boot2 section is like the first thing we put in there, and make sure that he's linked knowing that he's going to be in like RAM, but we're storing it in Flash, right? These are kind of like hand wavy what this means. And I don't really like, so the problem here is basically this step. To like run the Python script that generates this guy. I think that's weird and stupid. I don't want to do it that way. What I think would be way cooler, is if our boot2.s wrote directly into the boot2 segment. The linker script padded it with zeros, or this guy was like automatically padded so that this was 256 bytes. And then we like overwrote. If we like spit out boot2.0, this guy will not be checksummed, but we should be able to just overwrite that section of the elf. If he has 256 bytes of zeros, we should just be able to rewrite the last 4 of them to be like the correct checksum. I think. So I kind of want to see, I want to explore that concept. And if that works, it's like kind of more complex, but also kind of more simple at the same time, right? It's like more complex because parsing this .o file is going to be like a pain in the ass. But like the build part of this becomes like way simpler, I think. I want to see if we can do that. Is this? Let's kind of checkpoint our current state here, huh? Boot2.s test.ld. I think that's what's in here. And maybe what is boot2 pad checksum here? We probably don't need that. That's part of the build. And then let's put a git ignore here that ignores the build folder. You lost me halfway. There's too much going on. Yeah, that's fair. That's fair. Hopefully as we get into it, it will become a little bit more clear. Okay. So I think step 1 is to make sure that we can spit out a .o file that is like the compiled version of boot2.s, but padded, right? I think that's possible. Somebody was saying that you could do that. Linker script pad zeros or something. I'm on 5 hours sleep in 3 days. That doesn't help you. You should sleep. That's fucked. I don't think that's good. Oh, nice. So what the fuck is happening here? What does this mean? So they're like, start the pad aligned to 512 bytes. Then they're saying, advance the cursor to where it is plus this amount. Sure. And then what does this mean? Byte 0? Not sure. This makes sense to me. Yeah. So if we're like, let's make a linker script here that takes the boot2 segment. Why do we need boot2 start and boot2 end in here? Oh, just to do this assertion? Sure. Then let's, align this to 256 bytes. Is that really it? That seems kind of reasonable. Okay. And then let's take like boot2.s. And can we link this with... Oh, I guess maybe there's no linking happening here. When we generate the .o file, I don't think we link. Linking is kind of at the end when you take all your .o files and you put them into an executable. So that means either we need to pad directly in the assembly, or we need to like rewrite the elf at the end. I guess we could try rewriting the elf. That seems kind of fine. Okay, so if we were to do that, we'd kind of be like, let's make boot2.s. Then let's use boot2.s or .o unpadded, unchecksummed to make our boot2.elf. Sure. This is mad because he's like, it must be 256 bytes inside, so that align trick seems to have not worked. Which I guess kind of makes sense. I'm a human. Let me look. Yeah, he's just doing it the other way. Gross. I want to do it just like at link time. So maybe we should try to understand this. We can ask the idiot. That guy knows all sorts of shit. What does this do? So shove this shit to the next 512 byte line address. This makes a pad section. This line calculates the amount of padding needed to align to the current section. Sure. The line writes a single byte with the value of 0 to the memory location, effectively padding the memory zeros up. Okay, this is what I'm confused about. So, like, I suspect, my understanding of this is that this byte 0 would only be written one time, which is confusing, right? It's like we would, like, advance the cursor and then write 1 0. Wouldn't byte 0 only write 1 0 at the end? Let's see if he agrees with me. Shut the fuck up. Fuck you. You fucking... This looks a little bit more reasonable though, right? I don't really believe this, but this kind of makes sense. I believe this part, right? So they're like, take, you know, however many things are left to make us to get to 256 and repeat a 0 byte until you fucking get there. That seems kind of reasonable. Okay. Compile. Syntax error. Okay. So this is just not valid. He's just a fucking lying piece of shit. LD linker script repeat. Let's see if like how wrong he is. LD linker script inject n bytes. Oh, you know what? Maybe the old version of this didn't work because this is supposed to say, this guy's not writing to the boot2 section. So that alignment, there we go. Wait, that's kind of hype. That's kind of hype. Okay, so can we look at what's in, I guess we look at what's in read elf segments boot2.elf. So this is 100 in hex, which is good. That's 256 bytes. And this thing is also 200 bytes. And then if we do like hex dump -c this thing, can we find those 256 bytes? It's here. So he's going from F00 to 1000. That looks right. That looks right. Okay, so before we get fancy, I'd be curious to know if maybe we should compare, maybe we should compile this thing both ways and compare. I like that. So we'll say, you know, we'll do, this is boot2 raw link .elf. We need to make test2.ld now because we need to have two linker scripts. One that does the padding by itself and one that doesn't. Okay. Okay, so our expectation here is that they look almost exactly the same, except that the R version doesn't have the checksumming correct. That's kind of my expectation here. So if we like diff boot2.elf and boot2 raw link.elf, can I like force it to do this shit? Treat all files as text. That doesn't help me, huh? Can we maybe diff the hex dumps of the two? Hex dump boot2 elf. So this guy should have the boot2 section. Okay, this isn't good. This is empty. That's bad. We fucked something up. Boot to new. We'll do this. So this guy writes the text section, and boot to new writes the boot to section. Okay. So this is like new, and this takes in new here. Okay. Compile. Let's compare these two again. Let's make sure. So this now is sane. Cool. He's got his checksum. We can hex dump boot2 elf. And now we see at FOO, he's got his starting shit. Then at the last line here, FF0, before his 256 plus result, he's got a little bit of shit here, right? And if we look at our new version, we have the same shit here. BE64, BE642001. That's the same here. And then we just are missing the checksum. Cool. So it would be interesting to try to, I guess, read this elf and replace the relevant data. So we know right now we can just kind of hard code the addresses. You know what? I was gonna say we should like parse the elf, but because of the way this works, do we know exactly where in the binary this shit lives? Let me see. No, it's not that simple. Okay. So for now, we're going to cheat. And we're just going to rewrite the elf in place and see if that works. But then later, we'll do it correctly. So I guess... I don't know if there's like other checksumming in here. But we know that our bootloader checksum should be the same in the two cases. So to hack this for now, we could kind of take this guy, look at his checksum, which is these 4 bytes, and just kind of hack our version. I need like a hex editor. I think bless is the one I usually use. But we should just be able to like hack this shit. Oh, okay. Consider using imhex or ghhex instead. Sure. I don't give a fuck. The fuck is imhex? Fancy. What was the other thing it suggested? Ghex? This looks way more like something I understand, but fuck it, we're already here. Okay, raw link. Fine. I didn't want to use you anywhere. Anyways. Fine. Does it mean I can keep drinking? Yeah, I guess so, because it's late. It's allowed. G hex boot to raw link. Okay. Oh, it's because this tmux instance was started over SSH. That's funny. Affirmative. Affirmative. Okay. Let's try this again. One sec. Dude, allergy season is starting. I hate that shit. My nose is gonna be an absolute disaster. Okay, let's try this again. G hex. And there we go. Okay, so we're looking for the last 4 bytes before hex 1000. So right here, we're looking to, we're looking to paste this shit from the other guy. So we're looking to put this stuff there. So we want 9450AB30. And then we save this. And I guess we just try to test if this boots correctly on this Raspberry Pi Pico still in that form. Because if it does, that means that this is a valid way to use this thing. So it means that it's sane, it's like allowed for us to just rewrite the elf as is. Okay. Boot to raw link.elf. Okay. Sure. Fine. Fine. We need DDB. I guess we need to install the programs we want to use. Fuck you, man. I can do what I want. Ah. Oh my god, dude. All right. GB. Okay. So that's interesting. Could not open build boot to raw link. So my assumption there is that there's like checksumming in the elf itself. That's kind of fun. Can we look at like elf file format? Right, I assume if we compile this thing. Oh, you know what? We were running from the wrong folder. Hold on, maybe that was fine. I might be a dumbass. Let's try that again. I shouldn't have rerun compile, but it is what it is. Hex dump -c, the valid one. And we're copying 94. So at the right spot here, right before hex 1000, here, it's 9450AB30. Okay. We want to run OpenOCD from this directory. Oopsies. Okay. So that's working. That, like, we can tell because if we disassemble from here for like plus 16, we're like running our breakpoint move in 100, add 1, and then branch back, right? We're just in that loop. So that compiled successfully, which means that it's valid for us to just rewrite that part of the elf before programming, which is hype. Okay, so I guess step 1 here is to do it the hacky way. So hacky way is like How do we want to do this? Thinking? Do we have Zig right now? Let's add it. Let's do whatever we're doing usually to get like the latest and greatest Zig 014. Where's an example of that? Here. Pico, shell Nix, paste. Okay. This works for me, and then we're gonna use unstable.zig and unstable.zls. Okay. So that should give us Zig, which should give us a standard library with a good CRC library in it that we can configure to kind of CRC however we want. And I guess we'll make a like CRC, we'll call this like checksum gen or something. I don't know, man. Or like checksum like elf patch or something, maybe? Yeah. Elf patch. That sounds kind of right. Nice. And I think we don't need to do anything more fancy than a main.zig. So can we do like, you know, import the standard library? And I guess we'll probably let's do like get me some arguments, please. You know, we'll do like general purpose allocator. Does this thing? This is just alias to debug allocator. Got it. But I don't really give a fuck. Okay, so we're like, give me some args. Maybe I actually want like a arena allocator backed by the page allocator or something. I feel like that's kind of nicer. Okay. So we're like, let's get some shit from the allocator. And then we'll say that the file name or path is args1. Boom. Okay. Zig run main.zig build boot to raw link.elf. Okay. Hell yeah. Okay. What's next? I guess we want to, for now, just look at the 256 bytes or whatever at the relevant spot. So we're gonna say like stud fs current working directory open file of path, and then can we like seek which one of these do we want? Seek to? Seek by from the start? What zig standard lib? Seek to seek. Relative to the current offset, relative to the beginning. That's what I want. Okay, so we want to look at from here, and we want to read 256 bytes from this thing. So we'll call this like the file buff, or like the boot to buff is gonna be, I guess, 256 bytes, right? Something like that. So we're gonna read into boot to buff. Boom. Okay. Then can we just look at what this shit is? So we're kind of hoping to see like the first 8 bytes full of stuff, then the remaining stuff full of zeros. Looks wrong. Is it FOO? I get that wrong? That looks more correct. So we have the first 8 bytes, 1, 2, 3, 4, 5, 6, 7, 8, a bunch of zeros, then the checksum. And I guess we want to calculate a checksum and get the same answer. That's what we're trying to do right now. So let's look at their parameters. Here. Okay. So CRC is equal to stud, CRC check key hash CRC, there we go. And the type is a U32 height. And then we have these parameters. So they have polynomial algorithm here. This stuff. Okay, so this is their polynomial. Their initial value is this. Reflect input is false. Reflect output, false. XOR output is 0. And we're hoping that if we run this over the first 252 bytes of the boot2 buffer, then we get the right answer. So we go like var CRC is this, CRC update with boot2 buff from 0 to 252. And we finalize that shit, and we see if we get the same answer. If we do, we're in such a fucking good spot here. Hello there. Hello there. I guess this is the, like, hasher, I guess we'll call it. I don't like KDE users, just joking. That's not a very good joke, but whatever. Is it like this? How do you... It's something like you do padding like this or something in this language? Yeah, it's like... Whatever, it doesn't really matter. We can tell that we got the right answer, right? It's just backwards, but they have 9450 AB30, 9450 AB30. So we are so fucking chilling. So fucking chilling. And so all we should have to do here is, I guess, write the file. So when we open this shit, I guess we want to open it for writing. Is that an option? What's in here? Mode read write, I guess. Or something. And then can we just go like seek to wherever the fuck the last 8 bytes are? So it should be whatever this. And if we write, I hope it overwrites, right? It should. I think. So can we write... is it even backwards? Yeah, because this is written as big endian. No. Wait, no, this is just right. This is a little endian representation of this number, right? Because this is the lowest bits, this is the lowest bits? Yeah, so we should just be able to write. So we should be able to write int here. We're writing a U32 from CRC as little endian. And I think that should do what we want. I think. So here we should be able to be like, we should be able to like write out this thing as Fuck it. Okay, so we run compile.sh. We look at the hex dump of our this guy. We should see no checksum, right? A lot of zeros, a little star here all the way to hex 1000. Wow. Nothing to do there. And then we just run our little patch tool. So it's like zig run elf patch main with boot to raw link.elf. And that should patch it. He doesn't like that. Why? File not found. Why? Oh, because I wrote boot to it instead of build like a dumbass. I'm a dumbass. Build here. Okay. So then, can we look at the output? That's really promising. Really promising. Which means that we should be able to open OCD, compile this shit. Like, it should just work now. Looks like it's working. Looks like it's working. Cool. I was kind of hoping that we'd see, file boot to build boot to raw link.elf. Yes. No debugging symbols found. Are there no debug symbols when we do assembly files? Like, I would love to have this shit tie back now, because it should really easily. We do compile with -G. We don't. Yeah, we do compile with -G here. I'm curious. I'm curious a little bit. Debug info assembly file GCC. Like, can we look at, fuck, what just happened? Can we do like a read elf header on this? He does just have no debug info, huh? That's kind of lame. Kind of lame. I would have loved to see that. Debug info for ASM files. Maybe. GCC ASM files debug info. So that was. We should probably like write down what that said. It was like WA, probably for assembler. ASM. Okay, what's like WA mean? WA, comma. Pass an option to the assembler. Okay. Sure, let's try it. If we're just like something like this, wrong one. We want to do it on the new guy. Or something? Then do we... Yeah, I don't see anything interesting there. So maybe it's not that simple. Maybe it's not that simple. With, oh wait. This says with debug info? This one does not say with debug info. Am I a dumbass? Like, isn't this line and this line almost exactly the same? Maybe debug info has to come from the text section? I wonder. This won't compile correctly, but if we wrote, like, text here, does that behave differently? Boot to new. Yeah, that's totally different. Can you generate debug info for code in non-text section? Is that, like, allowed? This seems like an idiot question. This seems like a question for the dumb. When I build, can I generate a .o file with GCC from assembly that contains debug info if the code is in a custom section, not text. When I run that command, it only generates the debug debug sections if it's in text. Let's see if he understands. We could try it. That sounds like fucking stupid, but I'm down to just fucking try it. I don't really believe him, but we're desperate. All right. He's a long piece of shit. Fuck. That's annoying. That's annoying because that was kind of like the goal, like the really nice part of this would be that I could see like line information, so we could see like comments and stuff in the assembly file if we wanted to from the GDB. That's what I was hoping to get. I think that it must exist. I just don't know how. If we... Can you use, like, linker script? Is that, like, allowed? Because I don't really think .os are linked. I don't think. But maybe? That'd be kind of interesting. Right? If we were, like, keep the text section. I guess we can try that first. This won't work later. But it does allow us to experiment here. So here we're like, spit out to text, right? But the linker script will copy everything from text to boot. And then if we program this thing, can we do like file build boot to raw link. Here we go. See, okay, this is what I was hoping for. Right? So now we have all of this information like directly in GDB, which is really hype. This is something that like the old way wouldn't have got us. Right? That's super fucking cool. Right? Now we have like this stuff working correctly. And if we were to go in here and write like a comment in here, how do you do like a GCC ASM comment? What's the syntax here? At? Really? Yeah, okay. So now we even get like this stuff here, which is kind of hype. So we could go like, I wonder if it works if we're like, you know, did something silly like put 100 in R0, right? Not that like we should need to write comments like that, but it doesn't hurt. Yeah, that's hype. That's hype. This is exactly what I wanted to see. So, unfortunately, it seems like GDB doesn't generate that information unless it's in the text section. So we're gonna have to resolve that somehow. But for now, I'm not going to bother. But I will come back to that later. Right, so now we compile the boot2 section, and he's like, we do the same thing, and he has no fucking idea. Right, which sucks. Which sucks. Okay, so this all works. We're really relying on like specific implementation details though. Our like elf patcher is kind of just hard coding the address that we know the boot2 segment is ending up in, but that could change, right? So we're going to have to like parse the elf a little bit, which I think might exist in the standard library. They have stood elf. So we might be able to like walk the elf segments, find our boot2 section, and load that part directly and rewrite it. I wonder if that's like possible. Who the fuck uses this? Is there like elf 32? Can I use this? Elf. Read? Okay, so there is this like header field. And is this thing kind of hard coded to match like our operating system? I don't think so. Seems like this should kind of work. Seems like it. Program header iterator. Okay, so like we should be able to. Okay, let's look. We should be able to be like, let's open this file as like stood elf header parse read. Yeah, read from some parse source, which is like f reader, probably. Probably try. And can we just like stood debug print the header? So we're gonna run from elf patch this with this. Okay. No function named SQL stream. Okay. Fair. Can we... What is this expecting? Maybe a file? Yeah, he likes that. He likes that. And can we go like header, section, header, iterator? Sections is this, while I assume that this is like this. And can we print this guy? He's mad because this thing probably has to be tried. Expected error union type. Okay, no. Is it here? Yeah, there we go. Cool. So we have some sections. Can we read elf sections of build boot to raw link? So we should iterate by name, I guess, until we find the name that works. So there's probably some way to like look up the name in this guy. I don't know how. Name. How do we find these? Dang, there's a lot of infrastructure in Zig, huh? Yeah, it's kind of sick. Because like I think their compiler kind of uses the standard library, so it's kind of like useful to have this stuff. How do we get our like name entries? Probably like section header num, section header string index. These are probably related. It would be hype to like be able to extract these things. I was even just talking about the language constructs. Oh, I see. Yeah, language constructs pretty nice as well. I think there's not really, it's not that much better than C. It has like optionals and errors, which is kind of, the optionals are kind of nice, but like I don't think that they're like necessary really. Somewhere in here they must have some way of like extracting the string table. They must. Okay, so this header, like, maybe not. I mean, it might be pretty high or pretty low level. That wouldn't like super shock me, I guess. So do we need to like look at like elf file format here? Okay. How the fuck does this shit work? Header sections, header sections. Okay, so like what is like count of section headers? So like where are they? Where are they? Okay, program header is tells the system how to create a process image, so we don't really care about that. Machine entry. So this is probably related. I guess one of the sections is probably the string table, right? Section header string table here. So when we see our like This is also probably relevant. So we have our name is the 27th thing in the string table, probably. And like his offset is, you know, here. Okay, so this is the boot 2 entry here, right? Because we can tell from the section header size here being 256. And this must be offset from start of file would be my guess. What's format this as hex, I guess. Needs a colon here. Yeah, okay. So this guy is the offset from the start of the file. And so the only thing we need to do is figure out how to like look up the name in this string table. Right? So can we look up like sh name elf? What the fuck is this thing? sh name. This specifies the name of the section. Its value is an index into the section header string table section. So can we look at the like string table? Like this member holds the section header table index of the entry associated with the section name string table. Cool. So this is in elf header. Okay. Then how the fuck do we parse the string table? Name associated with symbol table entries. If the name has loadable segment, blah, blah, blah. String table and symbol tables. Here we go. String table sections hold null terminated character sequence strings, commonly called strings. The object file uses these strings to represent symbol and section names. One references a string as an index into the string table section. The first byte, which is index 0, is defined to hold the null byte. Similarly, a string table's last byte is defined to hold a null byte, ensuring null termination for all strings. Cool. An object file symbol table holds information needed, blah, blah, blah. So I guess we look at the elf header. Probably. We're gonna play this really, you know, quick and like fast and dirty, I guess, is the way to say this. But okay, so we look at the header. They said one of these tables was the string table. So here the header has a... Do we not see this is supposed to have a like stir like string table. Stir index. Do we have that? Stir index here. 5. So this is going to be section 0, 1, 2, 3, 4, 5. The last section should be the string table, which, looking at this, does line up here. Section header stir tab. Which is maybe different than string table. That's interesting. But I think sh stir tab is probably the one we want, because otherwise this wouldn't make any sense. We could double check this by looking at the offset in the file that this thing is, right? So we have this guy offset at 10D0, and we're looking for something that has the word boot2 in there, right? Build boot2 raw link. So we're looking for something that says boot2. A null terminated boot2 I would expect is what we want to see, right? Yeah, he's saying that all of these guys should be null terminated. So where the fuck is this coming from in here? Am I stupid? I don't see boot2 null terminated anywhere. Oh, here. Boot2 here. So this is at 10B0-ish. You know, somewhere probably like 10B like 8 or 10 or something. Which is in stir tab, not sh stir tab. Right? So sh stir tab would be anything after 10D0, which would be anything like here. Oh, so it could be this. Which this kind of lines up a little better, right? This has symtab, stirtab, sh stirtab, boot2, arm attributes. That's these guys. So I think that's chill. I think that's chill. Okay, so we look at this head stir ring table index, right? And we look at section header iterator. Does this let us like skip? No, he only has next. So I think we do this. We do like 0 to string table index sections next, and we say const string table is this, right? Something like this. Then we reassign this thing again, and now we should be able to like copy the string table out, right? So we can do like string table or else unreachable, I guess. sh offset, I think, is the thing we're looking for, right? Offset from the file and size. Yeah. So it's like kind of like this. Strings len is kind of like this. And then we probably do like f seek to strings start. And then we say like strings is alloc strings len. And then we go like seek to here, and we do f read all into strings. And then I guess we probably like assert string like out like read strings read len is this, and then we like try to assert that this is the same length as what we allocated. That seems kind of reasonable. Okay. And then we can probably like find the indexes, probably. So do we know how many entries there are in this thing? Does it tell us? Okay. Object values these strings represent single names, blah blah blah. First byte is index 0, is defined to hold a null byte. I guess we could just fucking run it. Even if it does have that information, we could just figure it out ourselves. We could be like string starts. We can kind of say that we have, you know, something like this. What distro are you running? This is Nix OS. This is one of those things where I wouldn't necessarily recommend it to other people, but I like it. You know? Okay. So you go like string tab offsets, I guess. Just curious because of the GUI. Yeah, the GUI is like unrelated to the distro, to like the distro. Why wouldn't you recommend it? It's like the same reason I wouldn't recommend Vim, right? It's like fucking weird, annoying, has downfalls, but it also has like big upsides. Like, but I would never say to somebody, you should learn Vim. I think that's crazy, right? Because it's just like, it's such a high entry cost, and like using Visual Studio Code, pretty fucking good, right? And so Nix OS is kind of the same, where it's like, I feel like to use it, you have to have a pretty deep understanding of like build systems and like the Linux file, like how Linux like loads an executable, I think that like you kind of need to have like a pretty good understanding of that, because you're going to run into, at least I feel like I run into situations where there's not a Nix rule set for my program, right? And it's like, to understand why I can't just like take a program and run it, right? Somebody like some like company gives you an elf file that was built on Ubuntu, and you're like, how the fuck do I run this? It's like so fucking hard, right? Because like Nix doesn't have like user. And it's like, why the fuck not? And you have to understand the fact that like, okay, so like linking is like really complicated on this operating system, and just being able to like debug all that is like not trivial. And so it's one of those things where I feel like the upsides are there, but it's not worth, if you're somebody who's looking for Nix OS, you'll find it, right? Because it's sick. But it's one of those things where it's like, you have to be the type of person who's already looking for it to be worth using. You know what I mean? And so being like, you should use it is crazy. But if you hear about it and like it, that's different, right? So this is KDE? Yeah. Late night stream today? Yeah. I couldn't help myself. I wanted to do this. I wanted to do the thing. Okay. So I guess we just like rip the strings table. So we have like, I guess we like look for, I guess we could kind of do it like this actually. So we could do like strings, we could do like stud mem split iterator, like split on scalar on strings with the null byte. And then we could do like while var string iterator, while string iterator next string, this is, we could call this like strings buff, I guess. We can go like, and then this becomes strings. Yeah. So strings num strings is equal to s. Yeah, that's kind of nice. And then we say like num strings plus equals 1. Nice. And then when we iterate the sections now, we should be able to be like, section name is like just the string in the table. Yeah, strings at section dot shname. That kind of feels hype. Splitterator? Hell yeah, dude. I like it. Fine. This guy's such a bitch. Okay. So not great. Not great. But I don't really know why. Is it like this? F reference trace or something? How do I make this give me more context? Oh, this is a runtime problem. Oh, so it's writing the section name is a problem. Sure. So we need to say like if section sh name is less than num strings this, else unknown. There we go. I think that's a little bit more reasonable. So we have a lot of unknown, which is not good. And then also, this just didn't work. Because I'm a dumbass. I put quote 0, not just 0. Still not looking great. These names are really big numbers. Like really big numbers. 27. And there's like how many strings in here? Right, not that many. Right? Yeah, there's 1, 2, 3, 4, 5 or something. Oops. I guess I could have just printed out this as well. Right, so there's 7 strings or something? Why are they starting at 27? You know what I mean? That doesn't seem right. Its value is indexed into the section header string table section. Byte offset instead of index? Oh, fuck. You know what? You're probably right. You're probably right. Good fucking eye. So now we get strings bufflan here. Symtab, boot to, arm attributes. Yeah, that looks a lot more reasonable. And then we need to, okay, so we don't have to build this at all, actually. This is stupid and useless. We just go, like, string start is this. And then string end, or string len, I guess, is, we look for, like, the null terminator. So we go stud mem index of scalar. We're looking for the null terminator in string buff from string start onwards. Yes. Or else we fuck you. And then here we're like string end is string start plus string len. Okay. Yeah. Yeah. Hell yeah. Hell yeah, dude. Okay. So now we should be able to like find the boot 2 section, right? So we should probably find boot 2 offs. Right? And this is a function. I'm fucking mental. And this is gonna be like a usize, I guess. Okay. And I guess this takes in the file. Ooh, Jesus Christ. Okay. Probably this takes an allocator as well. And then we're also gonna have like a function here to like get string table, who's going to take in probably the header as well, right? And this is gonna return this. Yeah. So we're gonna read the header. Then we're gonna like get the string buffer here. And we're gonna return strings buff. Boom. Then we're gonna call get string table with alloc and f and the header. Cool. Then we are going to rip the sections. Right? And we're gonna be like, the name is, I guess it should be name start, name len, and name end. Yup. And so the name is strings from name start to name end. Hell yeah. And we say if name is boot2, return section.sh offset. Boom. Travis, thank you for the raid. What's up, you guys? What is up? We're on a little bit of an odd side quest today. We have okay, context. We'll give you the whole shebang. I have this controller. This guy. It's like an Xbox controller, except he's got little paddles on the back. Wow, hooray. Problem, paddles are handled by the controller firmware. So you can only remap the paddles to other buttons on the controller. I'm like, I just want more buttons, right? I don't want to reuse the other buttons. I still want those, right? I want to be able to use the D-pad. I want to be able to use A, B, X, Y. I just want 2 extra buttons. And so we're on this reverse engineering journey. Looking at the firmware image itself, I'm not very good at this stuff. I don't really know reverse engineering at all, right? But looking at the firmware package, it looked like it was like high entropy, didn't really show anything in binwalk, right? So it's like, there's not just like easy targetable data in the firmware package. So we pop this guy open, we find his brain, you Google this chip, brain doesn't really come up with anything. This is probably all the interesting information, but this guy might also have some interesting information. This is the EEPROM on this guy. If you Google this chip name, there's an EEPROM on there. So we're like, okay, if we want to like see what the fuck this thing does, then our only lead right now is like, could we dump the EEPROM and find some interesting info on there? Maybe there's a decryption key. Maybe the whole firmware image is on there. Who fucking knows? I don't. Right? And so we bought this Raspberry Pi Pico and a couple, instances of this chip. We've got a board set up, and we're slowly working through dumping the flash on this guy. Now, we could just do like the smart thing and use the Raspberry Pi SDK to like bang out an I2C driver to like write this stuff over serial, right? But around here, we don't do that because we want to understand how everything works at a really low level. What's the end goal again? I forgot. We want to reverse engineer the firmware on this thing so that we can remap the paddles to like their own keys. And so we are kind of trying to basically re-implement the Raspberry Pi Pico SDK. And today's topic is trying to get the bootloaders to work right. So the Raspberry Pi Pico, he's got, here we go, we got our picture from the beginning of the stream. He's got stuff in read-only memory, boot stage 1, right? Boot stage 1, he does stuff like make sure that you can recover this thing when you fuck it up, right? So he's like, I will pop open a USB driver and you can upload firmware to this thing, right? So he also has to be able to like write to flash and stuff, right? Then the thing you upload is kind of this form, this, right? So you have your executable comes in as like boot stage 2 is like the first 252 bytes, followed by a CRC, followed by the rest. And your job of boot stage 2 is essentially just like load the rest of your code. Travis, I'm gonna have to read the VOD tomorrow. First I have to raid and run. Work early in the morning. Have fun with this. Yeah, see you. Thank you so much for the raid. Apologies that I didn't talk to you more. Apologies, but thank you so much. So we are kind of working on this part right now. The fact that boot stage 2 has to be CRC'd. We are looking at essentially rewriting the elf file. So we have a boot2.s who basically does, nothing really too interesting, right? We say, could you put all this stuff in a special boot2 section, right? And we're not really doing any bootloading right now, right? We're just saying, put 100 in R0, add to him, and branch back. So just add to R0 forever, so we can hit the debugger and just check that it's kind of working, right? We have a linker script that basically says, hey, take all that shit from that file. You know, we said boot to a second ago. Well, just take all that shit and then make sure that like you pad it so that it's 256 bytes wide, right? And stick it in this section. Put it on the flash, but like link it as if it's going to go into this address because that's where the bootloader is going to load it. The problem here is that this is not checksummed, right? We need this fucking CRC. And so we are kind of in the middle of kind of writing an elf parser that finds where boot2 is in the output elf file that gets programmed through means that we'll gloss over. And we're just making sure that it rewrites the last 4 bytes of this section with the correct CRC. And we're getting pretty close. Okay. So I think we should just be able to call like find boot2 offsets with our allocator and the file. Funny, I wrote a elf parser 2 quite recently. It must be up in the air. It must be in there. Yeah. Love is in the air tonight, baby. Travis earlier was like, man, I thought I went down rabbit holes a lot. We just embrace it around here, dude. We love the rabbit holes. The rabbit holes are like more fun than accomplishing the goal. I guess if we go through all this thing and we don't find boot2, I guess we just crash. Fuck it. So I think we should just be able to be like, here we go. This guy's mad because this guy needs to return an error. This guy probably also needs to return an error, which means that get string table, we probably need to write try, and then on find boot2 offset, we probably also have to write try. I just had to write my own because libelf is really annoying. Yeah, we're kind of lucky that Zig's standard library has like enough of an elf parser that's, you know, for what we need. We don't need much, right? We basically just need to read like the segment headers, which is essentially just this, which is not too bad. Not too bad. Okay. So we should be able to be like, seek to the boot2 offset and write to the boot2 offset. Boom. And I think that's it. I suspect if we run compile.sh now and we look at the output of this guy, we should see our boot2 section here with appropriate checksum here. Let's go, baby. And if we program this thing, oops, GDB. Hell yeah, dude. Hell yeah. Here's our fucking code, baby. Hit the breakpoint, upload 100 or set a register to 100, add 1 to it forever, and branch back. So that's pretty hype. Pretty hype. The only thing that we're missing now that would have been nice would be the ability to tie back the debug info, right? Because earlier we found that you know, it only generates debug info if it's like the text section. But it's a problem for another day. Problem for another day. This is looking pretty promising. Pretty promising. Also, probably our build system, we probably shouldn't modify this file in place. We should probably copy paste it because makefile rules and stuff, but this is good enough for now. Apologies for you guys who just came in. You happened to come in at the very end of the stream. It turns out that this just works now, and I don't have anything else I want to do right now. This is already like an off-schedule stream, so we're at an hour and a half-ish. Things are working. I'm happy with the progress that we made today. So I'm going to call it. So apologies to people who came in with the braid. We're going to forward you on to someone else. If you guys like what you saw, we stream most days 12:30 to 4 o'clock Pacific time. Today is kind of an odd day because I just kind of felt like streaming late because I wasn't planning on streaming, but I had a problem I wanted to solve, so here we are. So this VOD will go up on the YouTube channel, which is linked in the Twitch description if you want to check that out. So some VODs go there if I think that they're like things that can be titled and thumbnailed essentially. But some VODs do not. And if you want to access to all the VODs, including the ones that I don't really think have good titles and thumbnails, then please consider supporting on Patreon, Twitch, or YouTube. If you join on YouTube or sub on Patreon or sub on Twitch, you get access to the remaining VODs. This content will end someday, but that day is marked by a dollar amount in my bank account. So every dollar I make doing this extends the content by some unknown period of time. So please just consider, but no worries if you don't. Otherwise, I think that's it. YouTube, peace out, and Twitch is find someone to raid.